ever look up at a hazy sky on a really dry day and just wish you could, I don't know, snap your fingers and make it rain? Well, what if I told you that for decades, scientists have been trying to do pretty much exactly that? Today, we are diving deep into the really fascinating and, yeah, sometimes controversial science of cloud seeding.
And that's the million-dollar question, isn't it? Can we humans actually just flip a switch and start a downpour? Well, the answer is a little complicated. It's not magic for sure, but it is some seriously cool science.
So, to get to the bottom of this, to really figure out how we can influence the weather, we have to start with the core idea. So let's just break it all down.
Okay, so at its heart, cloud seeding is pretty much what it sounds like. Scientists seed clouds with these tiny little particles to try and encourage more rain or snow to fall. But you gotta notice the key word here, existing. And that is the crucial detail. We're not talking about creating clouds out of thin air.
And really, this is the most important thing to remember about all of this. You can't see at a perfectly clear blue sky and expect a thunderstorm to pop up. Nope. You need a suitable, moisture-filled cloud to even get started. Think of cloud seeding as an enhancer, not a creator. It's just giving nature a little nudge.
So, how does that nudge actually happen? What's the secret sauce that convinces a cloud to finally let go of all its water? Let's get into the mechanics of it.
You know, it's actually a pretty logical four-step process. First, you've got to find the right cloud. Then you introduce something called a seeding agent, and we'll talk about what those are in just a second. These little agents act like tiny magnets for water vapor, helping all those minuscule droplets start clumping together. And once they get big enough, heavy enough, well, gravity just takes over, and bam, you get rain or snow.
Now, not all clouds are created equal, so there isn't some one-size-fits-all approach here. The method you use depends completely on the cloud's temperature. You've got what's called warm cloud seeding, and you've got cold cloud seeding.
The real game changer here is temperature. So, for warmer clouds, that's anything above freezing, scientists use simple things like salt particles. The salt is great at attracting tiny water droplets, helping them merge and grow into proper raindrops. But for cold clouds, the ones below freezing, the whole game changes. For those, they use something like silver iodide, whose structure looks a whole lot like an ice crystal. This encourages the supercooled water to freeze, creating little ice crystals that grow and grow until they're heavy enough to fall as snow, or maybe melt into rain on the way down.
Okay, I know, this all sounds incredibly complex, so why would we go through all this trouble? Well, it turns out the potential applications are huge, and they address some of the biggest problems we're facing today.
I mean, the most obvious one is fighting drought, right? Making it rain more for crops, filling up reservoirs so we have more drinking water. That's a big deal. In colder places, you can use it to boost snowfall, which is awesome for ski resorts and for the spring melt that feeds rivers. But more recently, it's been used for something totally different. And this is a perfect example of its versatility. In cities like Delhi, where they face these horrible air quality emergencies, a good rain can literally wash the pollution right out of the sky. It's a really fascinating, though definitely temporary solution for getting some immediate relief when the air becomes dangerous to breathe. But, you know, as promising as all of this sounds, we have to be realistic. Cloud seeding is absolutely not a silver bullet, and it comes with some pretty significant challenges and limitations.
First, and we can't say this enough, it's the big one. You need the right clouds. No clouds, no seeding, no rain. Simple as that. Second, it's actually really hard to prove how well it worked. I mean, did it rain more because of the seeding, or was it just going to rain that much anyway? It's also super expensive. We're talking planes, special equipment, perfect timing. And yeah, for problems like pollution, it's really just a band-aid. It doesn't cure the underlying problem.
So, after looking at the science, the uses, and all the challenges, what's the bottom line here? Where does this technology actually fit into our future?
At the end of the day, here's the takeaway. Cloud seeding is a really helpful tool, but only in very specific situations. It can absolutely provide critical, temporary relief from something like a drought or a pollution event, but what it can't do is solve the root causes of those problems. It's a supplement, not a substitute, for real long-term environmental strategies. And that leaves us with one last thing to think about. As we keep facing more extreme weather and environmental challenges, is cloud seeding a brilliant piece of human ingenuity we should be pouring more money into? Or is it just a costly, temporary distraction from the much bigger issues we really need to solve? The debate on that is definitely still going.